Geometry, Unit 2, Section 5, Unknown Angle Proofs with Auxiliary Lines. So in the previous video, I discussed proofs for the first time, really. I'm sure I've kind of mentioned it here and there, but we did our first actual proof over here where we proved something was equal to something by using the knowledge that we know of, like 3 angles of a triangle add to 180, vertical angles are congruent, and I can substitute things to prove different expressions. But we're really doing more of that. Like, I want to prove that z is equal to x plus y, that this angle is equal to the sum of these angles here. So we're not doing anything new in that sense, but what is new is we're going to be using auxiliary lines. Auxiliary lines are lines that we add to the problem. And there's 2 types of auxiliary lines. There's lines that you draw completely new, like I could draw a line like that forming a triangle here. And then there's lines that you extend, and I'm a much bigger fan of the extension auxiliary lines. I don't like just drawing lines that are brand new lines. I find it much more helpful to extend lines that are already there. Like this line, for example, I would extend this line to be like that. Or it would have been the other way, but I think that was the best option there. And the reason for that is it just makes it a little bit easier. It's already a line that's there. It's much easier to extend that with your straight edge. Because if you were to add a line brand new, what if you don't put it properly in the right place? Like I could add a line like that to form a triangle, and that would be valid. But if I draw on a line like this, again, it's still valid, but I think you're opening yourself up to potential for mistakes. But extension auxiliary lines, they're pretty safe. So you can do that whenever you want. And if you have a strange, weird parallel problem like this, sometimes it's helpful to do that. Extend the parallel lines or extend a transversal so that it reaches all the way across. Because now I see that this angle x would be corresponding with this angle x over here. So I see that those are there. And this angle y is vertical with that angle y. And I now see that x plus y adds to this exterior angle z. So that's actually how I'm going to prove this here. And without this angle over here, it would have been really difficult. And that angle was a creation from drawing in this auxiliary line here. All right, so let me write this proof out now. Now I kind of explained my my strategy. Let me call this x2. All right, this way I could say that angle x is congruent to angle x2 because corresponding angles of parallel lines are congruent. I'm abbreviating corresponding. I'm okay if you do that. I'm using the angle symbol for angles. I'm using the parallel symbol. I'm using the congruent symbol. The corresponding angles of parallel lines are congruent. And notice that I have to give this a name, though. I couldn't just say, something. I needed to say this angle is congruent to that angle. So I gave it x2. I could have put a new letter there. I could have called it a. But you need to give it a name sometimes. Sometimes we'll just put a 1 there and call it angle 1, stuff like that. So we got to give it a name. And then what else? We have y2 here. That I know that angle y and angle y2 are congruent. Angle y is congruent to angle y2 because vertical angles are congruent. Vertical angles are congruent. And then I can say that angle x plus angle y, basically I can now say this. Or maybe I should first say, I should first say that these 2 angles plus z are that, and then I could switch to these 2 angles plus z because of substitution. So that's what I'm going to do here. So I'm going to say that angle x2 plus angle y2 equal angle z. Because why? Because of the exterior angle concept that we've discussed. So how do I want to phrase that? Let's say that the 2 non-adjacent interior angles of a triangle sum to the exterior angle. Could have said an exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. This is basically the same thing, just kind of backwards. So I think that sounds pretty good. That works. And then lastly, I'm going to switch that to be regular angle x, not x2, x1 plus regular angle y, not y2, equals angle z by substitution, which is what I wanted up here. And I could do that because x2 and x are the same thing, so I could swap that out with regular x, and y2 are the same thing, so I could swap that out for the y, and there we go. Is that the only way to do this problem? No, I'm sure we could come up with something else, but it was a valid one, and it was all kind of accomplished by drawing in this auxiliary line and extending this line here. If that wasn't there, that would have been kind of tough to do. I've seen this problem with drawing a line here, forming a triangle, but I like this method a little bit easier. Let's do another example. All right, I see a bunch of parallel here, and I want to show that D plus B, so these two angles add to 180. So, well, how can I do that? Well, I see this line is parallel to this line, but this is over here and this is up here. Well, why don't I extend this line just like that? That's my auxiliary extension right there. And I think that's probably all I'm going to need to do, because I see that this angle D is going to be corresponding with this angle over here. I'll call it D2. So D and D2 are corresponding, and these two angles are now same side interior angles of parallel lines, and they do add to 180. So that's it. All right, so angle D is congruent to angle D2 because corresponding angles of parallel lines are congruent. And then we got that angle D2 plus angle B equals 180 because same side interior angles of parallel lines are supplementary. So therefore, since D and D2 are the same thing, I could swap out D2 for regular D. Angle D plus angle B equals 180 by substitution. We see that used a lot in these little angle proofs that we do here. And that is D plus B, except or B plus D, D plus B, that's the same thing. I could flip it around because of the commutative property, but I think that's good enough. All right, so we're gonna continue practicing these angle proofs, but this time you might have to extend a line or draw in a new line. And again, I could have done that another way. I probably could have connected maybe angles A and C to form a triangle in here and done something along those lines, but I think the extension is definitely the way to go. All right, see you.